The unit is operating in the largest refinery in Colombia. The waste feed that you see is 38% oil, 45% water, and 17% solids coming out of the refinery, where they're using polymers to where it can maintain that much liquid content. They will discharge it into the feed hopper. It will be metered out of the bottom through a hydraulic motor onto the slinger belt, that carries it up to the surge hopper at top of the unit and fed directly into the rotary kiln. This is the feed hopper. They will put the feed material into the conveyor belt that takes it up to the surge hopper, where it goes from the surge hopper, enters the rotary kiln. It's a single pass. The solids come through. The solids are discharged out the left end of the kiln here. The discharge, the oil and water vapors are pulled by the ID fan out of the feed end. The requirement for the stack in the refinery is a 50-foot stack. Normally these stacks are much shorter. The discharge coming out of the stack is an invisible plume. This is a discharge into the rotary kiln, comes through the bellows, which creates the seal, drops down into the Platco valves that you see operating to create the seal to prevent oxygen from getting into the kiln, drops into the discharge auger. On top of the discharge auger is a hood, which is just there for expansion of steam as you're rehydrating the discharge material. This unit is a 2-trailer unit. You will see the primary unit on the right, which is the rotary kiln. You're looking at the discharge end. On the left, you'll see the control room, a secondary trailer with a control room, a heat exchanger for air to liquid heat exchanger, and your condensing tanks on that second trailer. You'll see the pipes coming from the primary unit to the secondary unit. One is bringing the vapors over to be condensed. It goes right into the condensing tanks. The return is the non-condensable vapors going into the heat jacket. This is a unit, same style unit, operating in Nigeria. Here it's treating 20% oil, 20% water, and 60% solids. Much shorter stack. We're not inside of a refinery. Again, it's a clean stack. The emissions are invisible. You'll see the same vapor recovery lines coming over to the condensing trailer, which will be to the left. The ID fan will pull the vapors from the kiln that are desorbed, bring it into the first tank, which is the oil tank, where we'll spray hot oil that condenses only the oil. The water is not condensed in the first tank. Then it pulls it over through the second tank, where we're spraying cold water to condense the steam. Again, this is the trailer, the secondary trailer. You'll see the control room first. The blue is the air compressor. You see the liquid to air heat exchanger with the tanks in the back. This is the feed in, where you're feeding the material into the kiln. The 10-inch pipe coming out of the top is the vapors that are being removed from the kiln going over to the condensing system. The bottom trough is the feed material going into the rotary kiln. It's coming from the surge hopper, feeds directly into the kiln. The motors that we have are hydraulic motors for low RPM, high torque applications. You'll see the spray bars and the pipes coming over to the condensing system where they're spraying hot oil. On the top of the kiln, in the front of it, you'll see the inspection hatch, which is removed to do maintenance inside the kiln. That is the access to the rotary kiln. This is an oil condensing line. The line in the background is the non-condensable vapors coming from the ID fan going back into the heat jacket where they're destroyed. This is your water and your oil and your water tank, your condensing tank on the condensing trailer. The vapors are pulled through these. The spray bars sprays either the hot oil or the cold water to condense, whatever the case is. You have the pumps at the bottom, which will take the condensed liquid, send it through the heat exchanger, will cool the condensed liquids, water and oil, and return them back to the spray bars for the condensing system.